This is section 11.3, combinations. In the previous section, we considered the number of ways a club with 10 members could elect a president and a vice president. What if, instead of electing 2 officers, they just needed to pick 2 people to attend a conference? Is it different? Order does matter in the first example because there is a difference between a president and a vice president. So the order that people are chosen in matters. But if you're just picking people to go to a conference, does it matter if you're picked first or second? No. Order matters because there's a difference between the 2 positions for the first one, but order doesn't matter at all here, okay? So when you need to do this and the order does not matter, it's called a combination, not a permutation, okay? Permutations, order matters. Combinations, order does not matter. Now for these problems here, we're just asked to decide whether it is a combination or a permutation. Okay, so basically, does order matter or does order not matter? A medical researcher needs 6 people to test the effectiveness of an experimental drug. If 13 people have volunteered for the test, in how many ways can 6 people be selected? We're not asked to solve it. In fact, it specifically says do not solve. Just does order matter? Well, we just need to pick 6 people out of the 13, and it doesn't matter what order we pick the people in, so order does not matter. This is a combination. Okay. 50 people purchase raffle tickets. 3 winning tickets are selected at random. If first prize is $1,000, second prize is $500, and third prize is $100. In how many different ways can the prizes be awarded? Okay, so we have 50 people, 3 people win. Does it matter what order things are in? Is there a difference between being picked first, second, and third? Yes, because the prizes are different. So since order matters here, this is a permutation. Okay. How many different 4-letter passwords can be formed from the letters A, B, C, D, E, F, and G if no repetition of letters is allowed? Okay, we can't repeat them. Is A, B, C, D different from D, C, B, A when it comes to a password? Well, yeah. It has to be entered in the same order or your computer's going to get mad at you. So order does matter here, so this is a permutation. Okay. Now, 50 people purchase raffle tickets. Sounds familiar. 3 winning tickets are selected at random. That's the same. If each prize is $500, in how many different ways can the prizes be awarded? Well, the difference between this problem and this one is the prize. Here we had 3 different prizes, and it mattered whether you were first, second, or third. But here, if everyone's getting 500, then there's no distinction between being picked first, second, or third. So order does not matter here, and this one is a combination. Okay, so we have a formula here. The formula for combinations of n things taken r at a time. Okay, this is somewhat similar to the permutation formula in that we have the same basic pattern here. It's just a C for combination instead of a P for permutation. And the permutation formula was n factorial over n minus r factorial. The difference with the combination formula is that we also have an r factorial in the bottom. Okay, so this number goes in the top with a factorial. This number is going in the bottom with a factorial, and then you subtract these with a factorial in the bottom. Okay, Your calculators will also do these the same way they did permutations. They usually share a button or they're hidden under the same function. All right, so let's just evaluate each of these. From 10 items, we need to pick 6 and we want combinations. So 10C6 would be n factorial, so 10 factorial over 6 factorial, 10 minus 6 factorial. Okay, so we need to simplify this. And, well, since this is my larger factorial on the bottom, I'm going to do 10 times 9 times 8 times 7 times 6 factorial over 4 times 3 times 2 times 1 times 6 factorial, and that can go away. Of course, we don't need to worry about the 1. 4 times 2 is 8, so I could cancel those out. And then the 3 and the 9 can't reduce if I want to do it that way. So that's a 1, that's now a 3. So I have 10 times 3 times 7, which is 210. Or, use your calculator. There you go. Okay, so let's do the next one here. 24C4. Okay, so 24 factorial over 24 minus 4 would be 20 factorial, 4 factorial. 24 times 23 times 22 times 21 times 20 factorial over 4 factorial, 4 times 3 times 2 times 1 times the 20 factorial. Well, 4 times 3 is 12, times 2 is 24. So basically I have 23 times 22 times 21, which is 10,626. And of course you can enter this into your calculator as well.